Okay, isosceles triangles are kind of special. Got some parts to them. So you might want to write this down. These are kind of special. Isosceles triangle, as you saw, has at least two sides that are congruent. So I'm going to orientate it this way. It's kind of the traditional way to orientate them. When you see two marks like that, you'll know that the triangle is isosceles because it's got two congruent sides. This down here is called the base. So that's the base of your isosceles triangle. This angle and this angle here are called the base angles. Base angles, like that. And then up here, this is called the vertex angle. What you're going to see is you have some difficult definitions, words you might not have encountered before, like scalene triangle. Scalene triangle is going to come up a lot. Triangle with no sides or angles that are equal. So scalene triangle is going to show up. And then you're going to see the vertex angle of an isosceles triangle. So some of these things you're not familiar with, you're just going to have to get used to using them like that. Okay, the other part of what we need to talk about today is called assumptions. Now, assumptions in math are pretty much the same thing as assumptions in the real world as well. Or in the non-math world. I shouldn't say real world because this is the real world.
Non-math.
Okay, I'm going to zoom in on this picture and we're going to talk about it a little bit. Okay. Where's the black pen?
You want to just turn that around the camera. I can't do it.
What you're going to see is there's going to be cases where it's okay to just make an assumption. It's implied. There's going to be other cases where it's not okay to make the assumption. So we'll kind of look at what's just in general. Well, it's okay to assume that when you have two lines drawn on a piece of paper or a board like this, that they are in the same plane. Like, usually they won't tell you that the lines are in the same plane. So if you open your textbook and you see it as a homework question, you can just assume they're in the same plane. If you see that you've got a line and that it's got points on it, it's okay to assume that those are co-linear. Okay, it's okay to assume that those are co-linear points, things like that. So real obvious things it's okay to assume. Here's what's not okay to assume. That if I have two lines that look parallel, I can't just assume that they're parallel, okay? Because they look parallel. You have to be told that two lines are parallel. You're either going to be told that in written form or they will have marks on them. So those two lines there, do they look parallel? Yes. Are they? I don't know. But here are the marks for parallel. There are these little chevrons. So these little arrows that go on there, those are the marks for parallel lines. Okay, so AB is parallel to CD. EF looks like it might be parallel, but you don't know. GH looks like it might be parallel, but you don't know. They have to have the marks. So here, you don't know. Here, if they have those little chevron marks, then you know. Yes, they are. Yes. Same thing with perpendicular lines. They might look perpendicular, two lines meet up. They look perpendicular, but do you know that they are? The answer there is no, you don't know that they are. They have to have the marks. So don't make assumptions about how things look is kind of what the point is. Here, it's got the mark, and so yes, those are. Same thing with congruent triangles. Here's three triangles right here. Are they congruent? Well, they have to have the correct marks. This has 1 mark, 2 marks, 3 marks. This one has 1, 2, 3. These two would be congruent. This one looks like it might, but it's missing the right combination of marks. It's got 3, 3, 2 instead of 1, 2, 3. Okay? So be careful about assumptions. That's what that's kind of